Hi, my name is Mohammed Shah and I'm from Group 13. So for our project, we are going to design a water level pressure sensor. This sensor can be used all throughout many industries for pressure management or fluid measurement. This sensor can be used for any liquids, so as long as they have conductive properties. The sensor must be calibrated to the resistivity of each fluid being measured. So how does it work? We have a tank with two perpendicular electrodes extending to the bottom of the tank. When there is no fluid in the tank, that gap between the electrodes has theoretically infinite resistance, and thus no electricity can flow between them. When we add a fluid, electrons will be able to flow from one electrode to the other. The resistance and thus flow of charge will be dependent on the amount of electrodes submerged in the conductive fluid. So as the water level increases, the resistance will lower, which will allow more charge to flow. The system will be calibrated to the specific qualities of the fluid being used, and once calibrated, we will be able to measure the height of the fluid and consequently the fluid pressure.
The materials needed for the preferred embodiment of this sensor are 2 electrodes made from a conductive material, such as copper. However, copper is very prone to oxidation, so aluminum might be a better choice. We will need precision resistors to create a voltage divider in order to measure the change in potential difference. As far as the sensor element is concerned, these are the only 2 components, other than the fluid being used. We will need a DC amplifier to create a constant voltage in order to measure the change in voltage. We will also need a DAC system in order to convert the analog signal into a digital signal to be interpreted by the computer system.
As the water level of the electrode increases, the resistance will decrease, which means the voltage of that we measure along the known resistor will be directly proportional to the height of the water. For the most simple design, we start off with the DC output, which leads into a known resistor, which then leads into the electrodes and completes the circuit. We have a voltmeter that measures the voltage drop along the known resistor, which can be used to figure out the voltage drop along the electrode. If we require more sensitivity, we can use a resistance bridge, which would help us get a more sensitive measurement of voltage drop.
So this principle of knowing the water level can be used in water level controlling systems, which can be used to manage water in a tank or reservoir without any human intervention. This principle can be used anywhere, from measuring water levels in dams, power plants, industry and household water tanks, and it could even be used for different liquids.